This is Lesson 2 in Chapter 3, Linear Functions. A linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b, where m and b are constants. We recognize this as the slope-intercept form. The graph of a linear equation is a line. Likewise, a linear function is a function whose graph is a non-vertical line. A linear function has a constant rate of change and can be represented by a linear equation in two variables. A nonlinear function does not have a constant rate of change, so its graph is not a line. So we want to look at all of these and tell whether the graph or table represents a linear or nonlinear function. We can recognize that it is a function if it's a graph by using the vertical line test to make sure. And then we want to explain our answer. So for number 1, we know that it is linear because it is a line, so we can write that. It is linear. It's a line. Okay? A non-vertical line, because a non-vertical line would not be a function. It would not pass the function test. So for number 2, we can say that that's not linear because it's not a line. So non-linear. Not a line. For number 3, since it's not a graph, we can't tell if it's a line or not, so we need to look and see if it's a constant rate of change. So as this increases by 1, let's look and see what the dependent variable is doing. Looks like it's increasing by 2. So it would have a constant rate of change, so therefore it would be linear. As x increases by 1, y increases by 2, so it is a constant rate of change. Let's look at 4. Increases by 1 for x, and y decreases by a varying amount. So the, so minus 8, minus 4, and minus 2. So we would say this is non-linear, and it's not a constant rate of change because y decreases by different amounts. Does the equation represent a linear or nonlinear function? And explain. Well, remember, if it is a linear function, it can be written in slope-intercept form. So 5, you can see, is already in slope-intercept form, so we would say that is linear. And to write it in slope-intercept form, we would maybe just fill in what m is. The slope is equal to 1, and the y-intercept is 9. Looking at 6, we can see that it is linear because it can be written as the rate of change is 3/5. M is represented by the rate of change, and the y-intercept is 0. If we look at 7, it cannot be written in slope-intercept form because it's a squared x, so it's not, we cannot write it in slope-intercept, so non-linear. Cannot be written start to connect some of these words here, trying to get ahead of myself. Cannot be written in y equals mx plus b form, slope-intercept form. For graphing linear functions, a solution of a linear equation in two variables is an ordered pair x, y that makes the equation true. The graph of a linear equation in two variables is a set of points, x and y, in a coordinate plane that represents all solutions of the equation. Sometimes the points are distinct, and other times the points are connected. So, if you have a discrete domain, it is a set of input values that consists of only certain numbers in an interval. So, for example, the integers from 1 to 5, graphed as distinct points. A continuous domain is a set of input values that consist of all numbers in an interval, so all numbers from 1 to 5. So we recognize this as a compound inequality where we're talking about the values from the numbers 1 to 5. So for example 3, you have a linear function m is equal to 50 minus 9d, and it represents the amount m in dollars of money you have after buying d DVDs. So in A, we want to know, the question is, find the domain of the function. Is the domain discrete or continuous? Well, let's think about what this means. The domain of the function would have to deal with the independent variable, or d, the number of DVDs. So you can't buy a fractional DVD, right? So the DVDs have to be whole numbers and at least 0. So we can make the domain a set of numbers, right? Because DVDs must be whole numbers and at least 0, meaning a negative number for a DVD wouldn't make sense. So we can say that the domain is, more than likely, well, it's definitely discrete. So let's say the domain is discrete and you could have 0, 1, 2, 3, 4, or 5. And I know this to be true because when we're talking about the amount of money we're going to have left, if we take 9 times 6 is greater than, we would get into negative dollars. So we don't have enough money to buy 6 DVDs. So you could kind of play around with or make a set of values to help you find out. So D and M, and this will help us with part B because we want to graph it. So sometimes graphing it might even help you answer part A. So we can check this out. And when we apply the rule, and we take 50 minus 9 times 0, we're left with 50. 50 minus 9, we're left with 41. 50 minus 18. 50 minus 27, and these aren't lined up sideways, sorry about that. 50 minus 36, and 50 minus 45. So these would be our ordered pairs that we would then graph. So I've given a graph over here. So 0, 0, 50 would be right there. Oh, this is going to be big. 1 and 41 would be about right there. 2 and 32. 3 and 23. 4 and 14. And 5 and 5. And of course, if you were doing this with a pencil, it would form a straight line, and you could label the points as well. So that would be part B as well, graph the function using its domain. So making a table and then graphing it. And our example 4 is the domain discrete or continuous, and explain. So you have your input values, a number of stories, X, 1, 2, and 3, output height of a building, Y, 12, 24, and 36. So they're talking about the stories of a building. The stories must be a whole number, and you can't start on 0. So it definitely would be, the answer would be discrete. And the reason why would be that the number of stories must be a whole number. Okay? And finally, you have a 20-gallon bathtub. It's draining at a rate of 2.5 gallons per minute. The number G of gallons remaining is a function of the number M of minutes. Does the situation represent a linear function? So for part A, one thing we can do is maybe do an equation here. So we want to know the number G, the gallons remaining, as a number of minutes, and the rate is 2.5 per minute. So we could have an equation that would be gallons remaining when you have 20 gallons and you're losing 2.5 per minute. So since we can put this in, that doesn't look like an M, a slope-intercept form, then yes. Yes, because as M increases by 1, G will decrease by 2.5. The rate of change is constant. So A, yes, constant. Rate of change would be one reason. Find the domain of the function. Is the domain discrete or continuous? In this case, think about this. The change is not discrete values because you can have things in between. So it's definitely going to be, we'll solve this equation. So So to find the domain of the function, and then we also need to know if the domain is discrete or continuous, one thing we could do is solve this equation. So I would subtract 20 from both sides. And the negatives are pretty irrelevant here. And this 20 is equal to the gallon, so this is the most that this would be equal to. So let me just go ahead and erase this right here. So another way of rewriting the equation is that the 20 gallons, which also makes this irrelevant, is equal to the rate times the number of minutes. So dividing both sides by 2.5 shows us that it will take 8 minutes to get to 20 gallons. So for B, we would say continuous. All right, and so time starts at 0. So 0 is less than or equal to M, which is less than or equal to 8. A tub can drain for part of a minute, so the time can be any value between 0 and 8, and that's what makes sense for it to be continuous. Then for part C, to graph it. So we could make a table of values, and I'll go ahead and count by 2s. 2, 4, 6, and 8. This would be our minutes. And to get our gallons, we could substitute it in here. and we would get, there are 20 gallons in the tub after 0 minutes. After 2 minutes, 15 gallons. After 4 minutes, 10 gallons. After 6 minutes, 5, and after 8 minutes, all 20 gallons have been drained. So we could graph. It would look something like this. When m is equal to 0, g is equal to 20. When m is equal to 2, it's 15. 4 is 10. 6 is 5. And 8 is 0. And again, if we were doing this with a pencil and paper and a straight edge, it would make it a lot neater so that you could see that it is a straight line. Okay, and these are not distinct, so we would definitely want to connect them.